Alright, so yesterday I was up till late and I was actually trying to implement this backpropagation further steps, and I came to know that my computational graph is broken somewhere, which is actually an electrifying news for me because uh, right now this model, this framework, this library, whatever you call it, has thousands of tensor nodes, right? Because I've implemented multi-head attention layer with 8 heads. And with actually with layer norms with free forward neural networks, so you can have an idea that how much processing is going on underneath. But the problem is somewhere when we were very excited about this backpropagation, I just broke my computational graph, which is a terrible news, because if you don't have computational graph working, then there's no way you can just flow backwards smoothly and update your gradient. So I was actually testing lots of different things. So I've written this method validate tensor graph, which actually validates at which point the graph is broken, and so it gave me a little idea that what actually is wrong. So I also test with compile this script with fsanitize equals address, which gives you information about seg fault errors. So if you just stumble upon any segmentation fault issue, or if you're trying to read or write from the memory which you haven't allocated, or probably you just go out of the bound, it just gives you an idea of where actually what actually is wrong with that. So you know, so I just broke my graph. I did a lot of different things to test this. This is actually my compile command, which I'm using right now. In case if I run this, let me just show you what's going on here. So fsanitize address and then attention tensor arena, and these are actually all the files. So I figured out, because I just fixed part of it. That's why you are not seeing exact error over here. Just it's just telling you the memory leaks, which you won't care about right now. So it does the computation, right? This is actually the output of multi-head attention, which is very cool. And these, forget about these warnings, we'll implement these functions later. But the issue is if I just try to like, let's say, traverse the graph, traverse it like so, yeah, like so, and you see I don't see any graph or any multi-head is nothing. So multi-head, yeah, multi-head nothing. This is out basically. So let me show you what it throws at me. So it just only traverses one node and nothing else, which is a leaf node. Yeah, that's true, which is a leaf node. The output of this thing will be a leaf node. But the thing is, there are lots and lots of tensors that are connecting this leaf node from root to leaf, from root to leaf, right? Which we're not, getting any clue of, right? So I think there's something wrong, because it's just not going at least even a one leaf backward. So we need to trace what exactly is wrong, right? So let's just see it. Let's just see it. So here is my, you see, MHA forward. So the output is coming from MHA forward, and MHA forward takes these tensors S, which I just created over here. This is a simple tensor. So think of it like, could be what you do with the transfer models is you just give text or whatever video. Let's consider text. So you have a large amount of text data, and you just pass it, and you just create the IDs of those text, that text, and the IDs mean token IDs. So this is, consider this basically a token ID. So I'm creating a token ID. So it's just a matter of getting actual text and converting it to some number. That's it. That's it. We'll be doing later when we'll be building Python interface for this. But right now, think of it as just like a token IDs tensors, right? Token ID tensors, and it has requires squared equals to. It should be, because once we set requires squared equals to 2, then every operation outcome will set requires squared equals to. So when I traverse this, it only traverses one node, which means that it's not going backward. There's something wrong. So let's see what actually is wrong. So out is coming from MHA forward, and if you go to MHA forward, this is MHA forward. Okay, it's taking the tensor. Okay, it's taking the MHA structure, and then what's going on here? So this has required squared equals to. When it will be multiplied by this, This will have required squared equals true. This will have required squared equals true. This will have required squared equals true. So far we're good, right? Till here everything is good. And in case, let's just do one thing. If I traverse graph and pass MHA V here, just in case to see if everything is working fine. And let's just comment this out and see what happens here. Dude. Does it traverse anything? Too few arguments? Yeah. Too few arguments. Why few arguments? And yeah, we are not passing the visited list, which we should. So MHA forward takes visited list as well. And I think I need to create visited over there as well. So okay, so MHA forward. Why don't we just MHA forward? It takes visited. Can we just create visited list over here like so, or like globally over here, and there should be like bool visited max nodes, right? And or should I create a function which returns a pointer to visited list maybe? No, it should be bool visited bool return list. Should be something like this, and this creates us bool visited max nodes, and yeah, like so. I less than global tensor ID visited visited I equals false, and this should return visited, which is right here. And okay, and now what we can do here is MHA forward. So this gives us return list, right? And just pass this list over here. Will this work? That's one question. What actually is wrong? Traverse graph. Traverse graph visited. Tensor.h. It takes root node and visited. That's what it takes. So yeah, that's right. $241. Are you serious? Oh, what am I doing? Alright, so it did try to traverse something. Caused by read memory access. Okay, let's just see here. looks like there's something wrong, so let's just say bool vislist. Let's call it vislist, and bool max nodes. Max nodes. No, not max nodes actually. Global tensor ID. Should it be like this? And global tensor ID plus plus, and populate this thing. Visit it. I equals false, right? And return visited. Right, like so. Vislist and bool um, visited is equals to vislist, and yeah, so this should return us a pointer to this visited list, which is a boolean list, right? And if I pass this over here, and if I go to image forward and just remove this from here, uh, detected memory leak. Alright, so detected memory leak. Let's just quickly check if this function is correct. Detected memory leak. Okay, so is this function correct? I don't think if there is anything wrong with this. I don't want to use malloc. This is not correct. So let's just say bool visited. Let's just use malloc. Uh, ID multiplied by the size of bool, and this should return me a bool pointer, right? Like so. This is if I call calloc instead of malloc, at the oh, we are not calling this traverse, man. The heck are you doing? All right, so that's right. Mm, bool pointer malloc and global tensor id times size of integer. Something is wrong. Still something is wrong. Visited equals with list. I think tensor global tensor ID should be 1 because we are creating at least one tensor. Uh, After the creation of this tensor, we should see some number incrementing, and I think there's fundamentally something wrong with create tensor, create new. Uh, yeah, so it increments the ID, and if I print it here, yeah, this is 1 and this is 0. That's the problem. So where exactly is this? I'm printing it over here. Global tensor ID in tensor file, right? So here and print f global, yeah, nope, tensor c global tensor ID. Okay, yeah, there it is. So we need to comment this out because it seems like it's working fine. And at attention, what we need to do is we need to simply print the ID of this output tensor, or we can actually print its metadata as well. So tensor get tensor metadata out, and that's it. And now traverse the graph. So we're having problems with traversing the graph, and this is 207, which is good. I mean, 207 tensors are created in multi-head attention layer. This is good. So ID is coming now, leaf node, and after that we don't have any node. So leaf node, and that's it. So it's not traversing all the way back, even though it's calculating the multi-head attention values correctly, but it's not traversing, right? So we need to see what exactly is wrong. So let's just, okay. So now we see that this thing is fine. I mean, the IDs associated with tensors are working fine now, right? And all we need to do is we need to trace why at the first place the tensor is not, like, the graph is not working. I mean, is it broken at some point? So traverse graph. So let's just see one thing. If I go to MHA forward, and MHA forward has these methods. So here the required squared equals true, which is fine. Here it should be true because metmults, if any of these has required squared equals true, then the output of this will have required squared equals true. So till here we are good. So let's just confirm this. So printf confirmation. Let's just call it debug. Debug and debug what? Okay. Traverse graph and mha dash v and visit it. And visited is what? Pool viz list. Viz list, is it like this? Viz list or viz list? I think it's like this. So visited, and let's put a exit over here. Viz list. Okay, viz list is not, so we need to add this in library as well. So in header file as well. So vim tensor.c. This is viz list, or I don't know what was the name of the function. Okay, so vim visit here. Okay, so where exactly is this function? So this is viz list, right? So let's just bring viz list over here. So vim tensor c, and this should be here somewhere, and it returns a boolean, right? Okay, so it returns a boolean. So tensor.h. This is going to be another function, void viz list, which returns nothing. Sorry, pointer to Boolean array. Okay, fine. Can we run it now? Conflicting. Mhm. Okay, so uh, sorry, it's a function pointer. Now run it. Okay, we got something. We got something. Let's see what we got. So this is for navigating files and this is for running. Okay, so let me put my cell phone on charging. So I'm turning my camera off because OBS is creating lots of different issues for me. And since I'm on Linux, you know that drivers are not very good. The video drivers and GUI drivers are not very good at Linux, so I'm just turning off my camera today. So let's just check. Either we have any errors. No, we don't have any error, right? This is where we are traversing. This is the tensor ID. And is it traversing from here? Okay, so MHA forward has this, so we've applied visited on this one, and this is coming from T and this, right? And tensor multiplication, this is the first one, this is the second tensor, and they all require grad. So even if you don't like put require grad here, so if I go to MHA initialize parameters, MHA init params, and we see we have set the gradients true. So in case if we don't even do this, the output should be same, because T requires grad, and if T requires grad, this is good. We're having this tensor, but we're not able to even traverse from here till back. So what exactly is wrong? It has two parents. So if it has two parents, can I print its parents? So let's just debug this thing. MHA forward, and okay, let's just not traverse here, and let's just go to MHA forward and try to understand what's wrong here. So we're exiting. Traverse graph. Is there a traverse method? Okay, so vim tensor c traverse graph. So traverse graph. So it takes node, root ID null, root ID equals true, tensor metadata, and then number of parents, root metadata. This is fine. So if it has parents, and we can see that number of parents are 2, then why we are not able to traverse at the first place? Why we cannot traverse it then, even if it has parents? Visited I. Why it's not okay, can I do something like this? If root operations null, int parents is equals That's root. And then half root node. Okay, so okay, that's fine. Now we're zooming in on exact problem. So the problem is in MHA forward method, we're not able to traverse back, and the reason could be leaf node. Okay, so let's just go back. The heck is wrong, man? Like T requires squared, that's for sure. And let's see if we go to MHA init params. Okay, it has two parents, so this has two parents. It has two parents, right? That's right. One is this, the other one is this one, and both of them are uh, visited itself. This is the actual tensor, which is MHAV, which is obtained using the tensor manual operation. Okay, and this should print three tensors over here, right? And let's just quickly test it too. Um, mm, When the output. We need to see its output and how we can do this. Okay, let's do one thing. Okay, like so. Um, Structured. So, okay, so I tested this, and it seems like our function is doing correct. It's doing the traversal correctly because you know what? Let me just tell you something over here. So what we have is we have MHA V. We have, let's say, V, which is let's say WV matrix multiplication of tokens, right? And I'm able to see these two um, these two tensors, this one and this one, these two, right? But I'm not able to see the V. So this was actually confusing me. So I cannot see V. I can only see these two tensors, right? The actual path which reaches this V. So I think our logic is working fine. If I run this now, we have one tensor and the second tensor. This is correct. So these two get multiplied and produce this one. Sorry, the V that we have, right? Okay, so it's something like this. So in case if I write it down here, if we have V equals WV tensor matrix multiplication tokens, and I can see the tokens. I can see both of them. I can see these two, but I'm not able to see the V, right? So this is where matrix multiplication is happening, and then we have tokens, right? So I think this is good for now. This is good. We can run further tests. So if I come here and check ATTN2, and this will be like MHA forward, forward. So till here things are fine. Yeah. uh, okay, so let's just bring it over here now, and this is working fine. Okay, and this will be also working fine, and so for this will also be working fine, right? And now we want to see whether this thing is good. So QK head score. So QK is basically tensor slice columns, right? And Q times DK, right? And how have we created this MHA DK? Um, Yeah, MHADK is basically an integer number, and this is also an integer, right? So this has only one parent, which is MHAQ, which requires grad equals true. Uh, requires grad equals true. That's right here. Okay, so till here we are good. And now if we want to see that if our QK reverses till back, so let's just bring it over here. It's debugging and put exit check. And let's just uh, bring uh, bring this thing over here, and uh, yeah, like so. And let's just do it for QK now, right? And let's see what happens. We got some more tensors, which is good. We got some more tensors. And what is this? Unknown address. Okay. Okay, but the most important thing is we're able to. Oh, wow, this is great. We can see the slice operation. That's right. And okay, if we just copy this entire thing, so slowly and gradually we are correcting our graph related issues. So vim out would be something. Boom, nothing. Out. Ha, yeah, all the warnings. Okay, so no, let's say nano. All right, so we're able to see the graph. Let's uh, okay, what is this? Address in SEJV on unknown address. Signal is scored by read memory class. Cannot provide additional information. Uh, okay, can we copy this entire thing? How can I copy in Tmux? Can someone tell me? Copy. Okay, you cannot copy, right? So this is good that we're seeing the graph, right? And we're seeing the graph till here. Everything is working fine till here, and then we have this KKVK head score. So I think something is wrong with this head score, and if I put this head score over here, uh, uh, yeah, so if I put head score, this will create problems because it returns the tensor QK, which requires grad, which is right here, requires grad, right? And I think there's something wrong with this head score. So the graph, the thing that is breaking our tensor is this particular thing, scale dot production attention function, right? So let's just quickly verify this as well. And let's just save it first and then run it again. Boom. Slice operation. Ooh, what is this? Looks like we're getting something. We're getting for different tensor IDs. Wow. This thing is working? Is it? It maintains the graph. See, we have different tensor IDs, tensor 0, tensor 11. All new IDs, man. This is great. Wow. Scale dot predict attention is also working fine, right? And now, yeah, so far so good. So far so good. Um, Concatenate. What does this concatenate do? Mm-hmm. Concatenate. Let's just see this. How do we create this at the first place? Tensor. Hmm. Um, tensor dot concat, and concat has all these things. Tensor create new. This is output. That's our core logic, and so the main thing that I want to confirm over here, this everything is under tensor operations, right? If everything is working under tensor operations, I am 80% sure that there won't be any problem associated with that particular thing. And there's only one method, tensor concatenate, and if we go ahead and do something like this, now there's only one way we can verify this. There's not only one way, but I think let's just do this, or even just remove this from here. This thing is working fine. This thing, even scale dot protection attention, which I suspected the most, but it's also working fine. Tensor concatenate. Let's just come down over here, and this is our output. And let's just see if you're able to get this output. And let's just run this. Everything looks good. We're able to get the output. I'll forget about this leakage, and let's now try to traverse again. So out, yeah. Let's see if we get something. So there's breakage at concatenate method, right? Or if I even traverse it one step back, the array that we are getting the data from, is there any way of like, okay, let's just quickly test this. Okay, so after testing, I came to know that there is something wrong with my tensor concatenate function, because it's not concatenating the heads. It's actually concatenating the head, but it's actually breaking our graph. Because if you see tensor concatenate method, um, we have this thing, right? We have tensor output, and but there's no actually uh, there's no we're not saving any parents information, right? So let's just say, so if um, let's just say tensor slice, yeah, there it is. If x requires grad and tensor concat, so let's just do this. So if heads heads at 0. So if heads at 0 at first index requires grad, out requires grad, true, out parents equals what? So will be our heads actually. So let's just check this config. So where is heads information? Yeah, this is heads. So yeah, we'll have that many parents, and okay. So num parents. This is actually num parents. Num parents. So our parents would be arena allocate dimension and what size? Heads times size of tensor pointer. And now let's just store for int 0 I less than heads out parents at I would be where's heads array? Heads. Yeah, so heads at I. This is heads at I. And then what? This is fine. Tensor OP. Okay. OP backward, tensor concat backward. This is fine, and OP. This is like OP. Tensor create A and dimension. We have in dimension and okay. So we have what out shape, right? And out calls is equals to out calls. This is an extra parameter which we are setting only for concat method, right? So this looks good, right? And so if we go to tensor.h, first thing that I want to that I want to set is concat, and the other thing that I want to set is for concat out columns. Let's just say this is int calls. Fine. Okay. Concat backward. Concat backward. Op expected this. A and size of op. Okay, so A and size should not be tensor. Really? Are we able to traverse the graph? Oh man, this is a huge, you can say, I don't know what. So, leaf node. So I still can't see all these tensors, right? And what else is going on? So it seems like it's traversing the graph. Yeah, so seems like it's traversing the graph. We'll have some further verifications. 204, 205, 161, 179, 180, 136, 154, 155. So you have lots of tensors, but they're not all of them. Right? So I want to see all the tensors using this DFS. That first we want to just successfully so let's just see if we have some concat function over here. It should be here, somewhere here. Okay, so let's just say grab concat. Yeah, we have op concat. Okay, so we have op concat over here, which means our concatenation function, concat function, also works fine. And this was it for now, and I'll see you in the next video where we'll be traversing more, debugging more bugs, and we'll making our system more mature, inshallah. So let me just fixed traversal needs validation. Perfect. So this was it for this video. Hope you have liked this video, even though it was very messy debugging sort of video, and I'll see you in the next one.